Hello and welcome back to another video. We're looking at chapter 3.6, derivatives of inverse functions. This is calculus 1. Here's the definition. I'm going to go over it. If you want to skip it, that's totally fine. I'll show you an example. Let f be a function whose domain is an enable I. If f has an inverse function, then the following are applicable. Let f be continuous on its domain. Then f inverse is continuous on its domain as well. Let f if f is differentiable and enable containing letter c, and f prime of c does not equal 0, then f inverse is differentiable at f of c. Here's the definition: the derivative of an inverse function. Let f be a function that is differentiable on an enable I. If f has an inverse function g, just keep in mind g is the inverse function, then g is differentiable at any x for which f prime of g of x does not equal 0. Here's the definition. Keep in mind, once again, g is the inverse function. Here's an example. Verify that f has an inverse, then use the function f and the given real number a to find f inverse of a. I'm going to keep going a little bit further, which is finding the inverse derivative. So here's problem 5, f of x equals to sine x, and the enable negative pi halves to pi halves. Here's a quick test, horizontal line test. If you can draw a horizontal line so that it hits the graph in more than one spot, is not a one-to-one. So we can test that out. Once again, I'm going to find a derivative as well, not only the inverse at number a. So here's the problem. F of x equal to sine x, and the enable, as you can see in the graph on this side, if you do the horizontal line test, you can see that it's totally fine. It only hits once, so it is a one-to-one function. Even the vertical line test to find out if it's a function, so it passes that, so we're good to go. Now from here, we need to find, once again, I'm looking for the inverse derivative, right? So number one, I need to find out what is f prime. So f prime is equal to cosine x. And then I also need g. Keep in mind g, it's basically the inverse function, right? So function. So that's what g is. So that's the inverse function. So in a typical algebraic way of formulating that, we can say this is equal y equals to sine x. This is our original problem. Now to find the inverse, we simply swapped the variables. We have x and y, so sine y. And now let's try to solve for y. I need to take the arc sine of x and the arc sine of sine y. So I took the arc sine. Just remember, sine and arc sine cancel each other out, and I'm left up with arc sine of x, which equals to y. And that is my inverse function, which, as I mentioned before, is called g in our problem. Now, let's find out what's g of 1/2. And g of 1/2 is simply arc sine of 1/2. Oops. If you're not familiar with these type of problems, let's bring the unit circle just to make sure that we understand the process. We're alternating basically from radians to rectangular coordinates. So the function g of 1/2, it's arc sine of 1/2. So basically the coordinates are in terms of cosine and sine, and we know that cos is in terms of x's and sine is in terms of y in our unit circle. So where does the arc sine equals 1/2? We see that 1/2 is here, as you can see there. So therefore that will be equal to pi 6. Once again, from rectangular to radians. Now that we have that, let's take a look at the g function, the inverse of it. So we need g inverse of pi 6. I'm sorry, 1/2. Let's do that. Oops. Go back. 1/2 is equal to 1 over, and then we need f prime, as you can see here noted. So f prime, it's on this side. That will be cosine of, and then we need g of x inside there. So everywhere you see an x, which I see here, it's replaced by g of x, and g of x is simply here, and that is our arc sine of x. So that will be arc. I'm going to use a different color to illustrate that. I'm going to use black. So arc sine of, once again, 1/2. Oops, let's use 1/2 in red. Okay, so we're almost done. So this is what we have so far. So I'm going to use the one a little bit here. So this is our setup now. We're ready to finish this problem. So we have g prime of 1/2 is equal to 1 over. And we have cosine of, and we know that arc sine of 1/2 is simply, I'm going to note it here, it's simply pi over 6. So this should be pi over 6. Oops, let's use the black color here. And now we know that this is equal to 1 over, and then cosine of pi 6. Once again, cosine it's on the x side, and then pi 6. Pi 6 is here in the first quadrant, and that is equal to the square root of 3 over 2. Now that we have radians, we're going back to rectangular, and this is equal to 2 over the square root of 3. Alright, that's our final solution. Thank you so much for watching, and please subscribe. Goodbye now.